Hello friends, here is another reasoning question. Homeothermy can be considered a feedback feed-forward type of homeostasis or homeostatic regulatory mechanism. Explain why. Let's understand what is homeothermy and then we will explain why it can be called so. But before that, have you subscribed to the channel yet and hit the bell icon? No? Go ahead and do it now. Okay, so what is homeothermy? It is body temperature regulation. Point number one. Thermy is temperature. So maintaining the temperature at a constant level, that is homeothermy. Now, body temperature is of two types. It has got two components. The shell temperature, which is the surface temperature or skin temperature, superficial temperature, and core temperature is the temperature inside the body within the core, as we can say, or temperature of the tissues, temperature surrounding the cells. That would be the core temperature, and this is just a diagrammatic representation for it. Now, shell temperature, the surface temperature, superficial temperature, skin temperature is expected to change with the ambient temperature. Whenever the ambient temperature is altered, our skin temperature is supposed to change. It is expected to change, but core temperature must be kept constant. Remember, core temperature is the temperature of the tissues, temperature surrounding the cells, and this temperature has to be held constant under all circumstances, because the cells need to function at their best, at their optimum level, and for that temperature needs to be kept constant. Now, this is just an example. Let's say body is exposed to cold temperature. What happens next? The shell temperature, that is skin temperature, and therefore the blood temperature will begin to drop. As we said, it is expected to change with the ambient temperature. So blood temperature will just begin to drop, but then blood, as it circulates, it reaches hypothalamus, and there are thermoreceptors in the hypothalamus. Now this, particularly posterior hypothalamus, will then induce shivering. You know, when we are exposed to cold, sudden exposure to cold, and there is shivering, induction of shivering, and because of the shivering, muscle contractions, body temperature will rise. So there is increased temperature. Now you can see here that this was the negative feedback so far as the shell temperature was concerned. What is negative feedback? Certain change occurs, then that change is negated and the parameter is brought back to the original level. That's negative feedback. So this is a classic negative feedback so far as the shell temperature is concerned. But shivering was induced in anticipation of a fall in the core temperature. Look, shell temperature already changed and then it was returned to normal by the shivering process. Heat was generated in the body. But basically, why the shivering was induced? We can say that it was in anticipation that now the body temperature is falling, so core temperature also will drop, and that will be disastrous to the cells functioning, and therefore before that could occur, the shivering took place and the body temperature increased. So core temperature was not allowed to drop. Before it could drop, the action was taken, and that is what is called as a feed forward regulation. In anticipation of some change, action is taken by the controller, and that's called as feed forward. So far as the core temperature is concerned, we can call it as this shivering, we can call it as a feed forward regulation, and therefore homeothermy or temperature regulation can be called as feedback feed forward or negative feedback feed forward. Negative feedback for the shell temperature, feed forward for the core temperature. That was the explanation for this particular statement.